Good evening, dear students. Today we are going to discuss, probability, and the topics what we are going to discuss today is total probability theorem and Bayes theorem. And this is in continuation of our earlier classes on probability. Before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students? Could you please confirm? Couple of students, can you please confirm that you are able to hear my voice very clearly and able to view the screen properly?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you very much for the confirmation. Okay. All right. So, let us consider, events. Okay. Few events like E1, E2, E3 up to En be the set of mutually exclusive and exhaustive events. Okay. So how we can describe those mutually exclusive and exhaustive events? So let me show you by means of a diagram. So let me first write down, dear students, here that let E1, E2, E3 up to En be the set of mutually exclusive and exhaustive events. So if you recall from our earlier classes that what is meant by mutually exclusive and exhaustive events, I can give you a pictorial representation of the mutually exclusive and exhaustive events. And for that, let me draw the diagram. Let me first define the entire sample space. As you see, this is the entire sample space, dear students. Okay. And inside that, so that sample space we generally define by the set S. And inside that sample space, in the set theoretic notation, what we can say is that there are events, E1, E2. So this is the event E1, this is E2, then this is E3, this is E4, then this is, we can say, E5, E6, and in that way it goes on. And it goes on something like this. So these events, if you look into it, that they are mutually exclusive. Okay. Why they are mutually till En? The last one is En. I'm not writing each and every one. So why it is mutually exclusive? Because if you look into that any two sets from U1 to En, there is no intersection, there is no element which is an intersection of any two sets, it means if you take any two sets and make their intersection, you will not find any element. That means, in other way, the intersection of any two among U1 to En is a null set. That is what we call it as an, mutually exclusive. And why they are exhaustive? Because if you make all of them union, you will get the entire sample space S. So that is what is called mutually exclusive and exhaustive. So we have both these two sets, not two sets, these n sets, E1, E2, E3 up to En, is a set of mutually exclusive and exhaustive events of sample space S. So we get these two things, right? E1 intersection Ej is equal to phi, where I is not equal to j and ij varying from 1 to n. And second thing is that union of U1, E2, E3 up to En is equal to the entire sample space S. Now, dear students, we are going to take one event A from that, sample space A. That means what? And that event A, I am going to describe, in a set like describing the blue color as you see. Suppose this is the event A. Okay, dear students. So let us take A be any event on S. then what you are going to get, dear students? So let me write down the statement, what I just said, that if we take A be any event on S, then what it will be? So it will be something like this. Any doubt at any point of time, never hesitate to ask me. If you look into it, that in that set, A is that it is the A is equal to that intersection of U1 and A, union intersection of E2 and A, union intersection of E3 and A, union up to intersection of En and A. That is quite evident. If you look into the set A, that is what I have given as a Venn diagram in the blue color, that set A you can construct by taking the intersection of the set A with all of these sets E1, E2 up to En, and then make an union among them. Correct? So then you get the set A. So how you get the set A? We are getting the set A, I repeat, dear students, as E1 intersection A, union E2 intersection A, union E3 intersection A, union ... up to En intersection A. Then what is the probability of the event A? So probability of the event A should be the probability of all the sets whatever you see in the union. Correct? Now, dear students, let's understand what are these sets. E1 intersection A, E2 intersection A, E3 intersection A, or up to En intersection A, all are mutually exclusive events. Why, dear students? Because E1, E2, E3 up to En, all are mutually exclusive events. As all are mutually exclusive, then definitely the intersection of this set with the same set like A, that should also be mutually exclusive. So what I wanted to mean is that E1, E2 up to En are mutually exclusive events. So let me write it down first, and then followed by let me explain. So what I was telling is that we see that E1, E2, E3 up to En are mutually exclusive events. So E1 intersection A, E2 intersection A, E3 intersection A, up to En intersection A should also be mutually exclusive events. And what is the property of mutually exclusive event, dear students? That there is no common element between any two sets. So probability of their union should be the sum of their individual probabilities. So what we're going to get it? We are going to get it this thing very clearly. Okay, I'm going to show you this thing, dear students. Let me repeat once more, dear students. What I wanted to say is that as we see that E1 intersection A, E2 intersection A, E3 intersection A, up to En intersection A, all are mutually exclusive events. So the probability of their union should be sum of their probabilities. Why? Because, intersection of any two sets is actually a null set, and probability of a null set is equal to 0. Let me give an example. Let's take two sets. What I'll erase it after that. So first understand what is probability of A union B, dear students. That is equal to, if you remember, that is equal to probability of A plus probability of B plus, probability of A plus probability of B minus probability of A intersection B. Now, dear students, if you look into it, okay, let me write it here. Probability of B minus probability of A intersection B. Now, as A intersection B is a null set, as we see that A intersection B is a null set, what we can say, dear students? We can say this value is 0. This value doesn't make sense. This value is 0. Correct? So then what we get finally, probability of A union B is equal to probability of A plus probability of B when A and B are mutually exclusive events. So now if we extend, instead of A and B, what we have here, dear students, E1 intersection A, E2 intersection A, E3 intersection A, up to En intersection A. Now all these sets, that is E1 intersection A, E2 intersection A, E3 intersection A, up to En intersection A, all are mutually exclusive. So probability of their union should be sum of their probabilities. That's what I wanted to say. So we get this equation 2, dear students, correct? I hope it is clear so far. Now, what we are going to do, dear students, is that, so whatever the values of we get in the equation 2, we are going to apply that in the equation 1. Okay, so then what we are going to get, if we apply the value of probability of E1 intersection A, union E2 intersection A, union E3 intersection A, union ... up to union En intersection A to the above equation 1, what we are going to get, dear students? We are going to get something like this. Let me first place it here, then I will explain. So we are going to get something like this, correct? So what we are going to get is that probability of A should be probability of E1 intersection A plus probability of E2 intersection A plus probability of E3 intersection A plus ... plus probability of En intersection A. That means now if you remember that conditional probability formula, dear students, is that if you recall that what is probability of, let me write it here, that what is probability of A slash E1. Probability of A slash E1 is equal to, dear students, it is probability of E1 intersection A divided by probability of E1, correct? That is what we know as a conditional probability, correct or not? Now, as we know this from the conditional probability, so that means probability of E1 intersection A should be probability of E1 into probability of A sub A slash E1. So that's what it has been written here. Similarly, probability of E2 intersection A will be probability of E2 into probability of A slash E2. And in that way, it goes up to till probability of En into probability of A slash En. So now, if we make in a summation operator, so we can write is that probability of A is equal to summation of probability of E1 into probability of A by E1. In fact, I can write like this, that probability of A is equal to probability of EI into probability of A by EI, where I is varying from 1 to n, where I is varying from 1 to n. And this is known as, dear students, as the total probability of the event A. Whatever you see in the equation 3, dear students, this is known as the total probability of the event A. And so now the above identity 3 is known as the total probability of the event A. I hope it is absolutely clear by now, dear students. Understanding is very important, because if your understanding is clear, then it will help you to solve the relevant problems on total probability theory, and whatever we are going to discuss now is the Bayes theorem will be very easy, correct? Now, dear students, if you see the event A, okay, the event A would have occurred due to the different causes. What is that? What I wanted to mean is that event A have occurred due to the different causes. It could happen, okay, it could happen due to the occurrence of any of the event E1, E2 up to En. Let me explain you this thing a little bit, okay, dear students. So for that, I would like to draw that same diagram here, okay, so that it will be very you can get it very clearly. So let me draw all these events E1, E2 up to En, the entire sample space A and the event A, once more by means of the Venn diagram. So let me first draw the entire sample space, dear students, and this is the entire sample space. Sorry. So this is the entire sample space S. Now, in that sample space, we have n mutually exclusive and exhaustive events. So this is E1, this is E2, this is E3, this is E4, this is E5. In that way, it will go till event n, En. Okay, dear students? Because all these events, if you find that they are mutually exclusive and exhaustive. Why mutually exclusive? Because if you take any two sets from E1 to En and make their intersection, you will get an outset. That qualifies to say that all these events E1, E2, E3 up to En are mutually exclusive. And why they are exhaustive? You take their union, E1, E2, E3 up to En, you will get the entire sample spaces. That is called exhaustive. So that is E1 up to E2, E3 up to En, they are mutually exclusive and exhaustive. Now, we are going to take that event A from that sample space A. So then, what is the event A will looks like? So suppose this is the event A. Okay. Now, let me give you an example. Okay, before I proceed further, let me give you an example to understand exactly in what context this is coming. Suppose, a doctor visits to its clinic. Suppose a doctor visits to its clinic, from home by means of different, commute. Someday he visits to the clinic by auto. Someday he visits to the clinic by public transport bus. Someday he visits to the clinic by his own car. Someday he visits to the clinic by a motorbike, like this. Now, every day it has been observed that the doctor is, late. That means what? When he, comes to the clinic finally, then he says that, okay, if he is supposed to come at 5 o'clock in the evening, but he's not coming at 5 o'clock, he is delayed. And it has been observed that, when he comes by bus, there is a different probability of getting late. When he comes by auto, it is a different probability of getting late. If he comes by motorbike, it is a different probability of getting late. Okay. So this is the case. Now, if you see that E1, E2, E3 up to En, these are the events that is coming by bus, coming by auto, coming by motorbike, coming by his own car, like this. And you see, all these are mutually exclusive. Why? Because when the doctor is coming by bus, at that time he cannot come by motorbike. Correct? And when the doctor is coming by public transport, at the same time he cannot come by auto. Public transport bus, I wanted to mean. When the doctor is coming to his clinic by bus, at that same time he cannot come by auto. It is meaningless. So that means all these events are mutually exclusive. And they are exhaustive also. Why? Because finally doctor is coming to the clinic by means of any of this commute. Na? So we see these events are mutually exclusive and exhaustive. Now, A is the event is that, doctor is late. So the event is that A is the event called doctor is late. Now, doctor is late due to any of these events, either by E1 or by E2 or by E3 or by En. Correct? So that is what I wanted to say by means of this example. So what I wanted to say, dear students, is that, that now the event A would have occurred due to the different causes. That means what? It could have, what I wanted to mean is that the event A, the event A would have occurred, let it come, the event A would have occurred due to the different causes. That is, due to the occurrence of any of the events E1, E2 up to En. Correct? Because if you resemble with the example what I gave, is that doctor is late. Doctor, when he visits to the clinic, is late. Means the event A have occurred. Okay, now that late, doctor is late because of either by coming by auto or coming by bus or coming by his own car or coming by motorbike, etc. So these are the events E1, E2 up to En. So the event A would have occurred due to the different causes, that is due to the occurrence of any of the events E1, E2, E3 up to En. Correct? Now let us consider the event A has occurred and we have to find the probability that the event A has occurred due to the occurrence of the event EI. Means what we are interested in context to our example, what I gave, that suppose one day doctor is late to reach his clinic. Now we are going to find that what is the probability that doctor is late due to coming by auto, or what is the probability that doctor is late due to coming by his own motorbike, or what is the probability that doctor is late that due to due to that public transport bus. So that we are going to discuss now. So what we are going to discuss, that suppose I repeat once more, that you see that doctor one day doctor is late to his clinic. Now the question is that what is the probability that doctor came today by bus, or what is the probability that doctor came today by auto when you see the doctor is late? Because doctor is late due to any of this commute. But what we want to find is that we want to find that doctor is late. What is the probability that he came by bus today? And that is what is the application of Bayes theorem. Now, before going to discuss further, let us understand what is Bayes theorem. Let us derive that Bayes theorem formula. Okay. So as I was telling, dear students, is that let us let me first write down this statement, and followed by I want to explain. So dear students, if you look into it, so what I write here is that let us consider that the event A has been occurred and we need to find the probability that the event A has occurred due to the occurrence of any of the event EI. Okay, means we need to find probability of EI subject to the condition A has happened. That means probability of EI slash A. That means what? Probability of the event EI subject to the condition the event A has happened. That is what is coming from the conditional probability. So we now derive the following. What is that? Probability of EI subject to the condition A happened is equal to probability of EI intersection A divided by probability of A. Correct? That is quite evident from that conditional probability formula. Now, what is probability of EI intersection A? That is nothing but probability of EI into probability of A subject to the condition EI has happened. That means probability of EI into probability of A slash EI. And in the denominator, what we get? It is the probability of A. And what is probability of A? Just by means of the total probability theorem, we found it out. It is a summation of probability of EI into probability of A by EI from I equal to 1 to n. So that we are going to get. Now, dear students, so what we are going to get from here, that we need to find that probability of EI, subject to the condition A has happened is this formula. And this formula means I just want to write it here and then I will explain. Is that what we get is that the probability of EI slash A is equal to probability of EI into probability of A subject to the condition EI happened divided by summation over probability of EI into probability of A subject to the condition EI happened. And this is what is known as Bayes theorem. And it has immense application, as I said, by means of an example, that when doctor is coming to the clinic from his home and he is late. That example. Now we want to see one application of Bayes theorem. Dear students, one problem generally comes from using the application of either total probability theorem or Bayes theorem. And I would like to solve one problem along with you. Okay, and the problem I'm going to give in the next page. So the topic what I'm going to discuss, it is not a topic as such, it is an example illustrating the Bayes theorem. An example illustrating Bayes theorem. And dear students, you just understand that example, what I'm going to explain you very thoroughly. And then after that, you need to make some practice. Okay. And the right place to make the practice is the online test platform at KonarClasses.com. Okay. Now, let me first, give you the problem statement. What is the problem statement? Let me write it down, the problem statement. So, let me first read out what I just, placed in front of you. The problem statement is like this. There are 3 urns, each containing, both red and blue balls as mentioned below. The first urn contains 6 red balls and 4 blue balls. The second urn contains 4 red balls and 6 blue balls. And the third urn contains 5 red balls and 5 blue balls. Okay, so if I give a pictorial description, dear students, is like this. Suppose the first urn, so let me draw the urn in the purple color. So this is the first urn, this is the second urn, and this is the third urn. In the first urn, so this is it is the first urn. It is second urn, and this is the third urn. Now, the first urn contains 6 red balls and 4 blue balls. So for the 6 red balls, blue balls I'm coming after some time. Second urn contains 4 red balls, and third urn contains 5 red balls. Now let's come to the blue balls. The first urn contains 4 blue balls. Second urn contains 6 blue balls, and third urn contains 5 blue balls. Correct? That is a pictorial description. Now, one urn is selected at random. That means you can either select first urn or second urn or third urn. Okay? Means all are equally likely and mutually symmetrical, so you can select any of the urn. And you draw a ball from it. So what is that? That one urn is selected at random and a ball is drawn from it. If the ball drawn is red, what is the probability that it is drawn from the first urn? So you do not know that from which urn you actually picked a ball. Suppose your eyes are closed and in front of you there are 3 urns, first urn, second urn, third urn. Your eyes are closed. You just put your hand in any of the urn. You do not know which urn it is and select a ball. After selecting the ball, you open your eyes and you found that, okay, whatever the ball you have selected, that is a red ball. Now, that red ball could have come from the first urn or second urn or third urn. What we are going to find? Probability. Find the probability that the red ball has been drawn from the first urn. That is the problem statement. And we are going to see, dear students, that how Bayes theorem is going to help us to find this probability. Now to do this thing, first what you need to do, we need to choose these events E1, E2, E3 up to, in this case it is E3, correct? So how to find the solution? So first we need to define what are the different events, dear students. Okay, so First, we need to define the different events. So here the events are E1, E2, E3, and A. What are those? Let me explain you, dear students, that the event E1 stands for that the first urn is selected. Event E2 stands for that second urn is selected. And event E3 stands for the third urn is selected. If you see, dear students, that E1, E2, E3 are mutually exclusive. Why? Because when you put your hand into the first urn, that means when event E1 is E1 occurred, at that time you cannot put your hand into the second urn. Na? That means E1 intersection E2 is null set. Similarly, E2 intersection E3 is null set, and E3 intersection E1 is also null set. So what we see that E1, E2, E3 are mutually exclusive, and they are exhaustive also, because ultimately you are picking a ball from any of these urns. So definitely, what, dear students, is that definitely that you are choosing that ball from any of these urns. That means it is exhaustive. That E1, E2, E3 constitutes the entire sample space. Correct or not? So by means of a Venn diagram, if I draw this particular problem in the set theoretic notation, it should be something like this, dear students. So if I consider this is the entire sample space. So suppose, okay, let me draw in a different color because I already used the purple color. So let me, this is the entire sample space. I draw in the black color, dear students. Okay, that is the entire sample space is. Now, in this sample space, you have three events, E1, then E2, then E3. You see, let me draw these events in different color. Let me draw the events in red color. Suppose this is event E1, then event E2, then event E3. Suppose this is E1, this is E2, and this is E3. That means E1 is that E1 stands for that first urn is selected, E2 is second urn is selected, E3 is third urn is selected. Intersection of any two sets is null set, and union of all these sets is actually the entire sample spaces. Hence, we can say that E1, E2, E3 are mutually exclusive and exhaustive, both at the same time, dear students. So many students are joining now as well. Okay, now, what is the event A? Event A is a red ball is drawn. So let me, give a Venn diagram notation of the event A. So this is the event A. As you see, I am drawing in the blue color. Suppose this is the event A. Now, if you look into it, dear students, that event A is that a red ball is drawn. Now, that red ball has drawn, maybe it is because of E1 or E2 or E3. You do not know, no, your eyes are closed. We are assuming when you pick a ball from any of this urn, you do not know which ball you are picking and from which urn you are picking. So that event A could have occurred either because of E1 or because of E2 or because of E3. Correct or not? Now let us find that how to find that the drawn ball is red. If we know that drawn ball is red, we need to find what is the probability that it is drawn from the first urn. Let's see how we can find it out, dear students. Okay. And for that, what you need to do is that, according to the problem statement, what you need to find? We need to find probability of E1 subject to the condition A has happened. A has happened means what? That red ball has been drawn. Okay. So A1 happened means what? The red ball is drawn. And now we are going to find what is the probability that a red ball is drawn from the urn E1. Means E1 has happened. So if you see this particular statement, what I just kept here, dear students, is that according to the problem statement, we need to find the probability of E1 subject to the condition A has happened, which means given the ball drawn is red, what is the probability that it is drawn from the first urn? Because E1, the event E1 stands for the first urn is selected. Now, to find this probability that U1 slash A, okay, Bayes theorem is going to help us. Okay, dear students. So how we can find it out? Okay, if we apply the Bayes theorem, okay, what we just discussed today, before giving this example. So the Bayes theorem tells something like this, correct? So if you look into the Bayes theorem, what you see is that we need to find probability of U1 subject to the condition A has happened. That is equal to probability of U1 into probability of A subject to the condition U1 has happened, divided by probability of U1 into probability of A by U1 plus probability of E2 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. That is what all you need to find. Now, dear students, let us see that how to find probability of U1. Okay, if you see, now let me draw the diagram once more, because as I am explaining it here. Let me draw the diagram once more, or you can find it out from here. Let me draw the diagram once more so that it will make more sense. So, if you remember the first urn, this is the first urn. This is the first urn. This is the second urn, and this is the third urn. So this is, let me write it down. First urn, this is second urn, and this is third urn. Sorry. Now, according to the problem, if you go through the problem statement once more, the first urn contains, I'm just drawing the diagram once more, that 6 red balls and 4 blue balls. Nah? So it has 6 red balls. Second urn contains 4 red balls. And third urn contains 5 red balls. Now blue balls, let me draw into the blue color. Inside that 6 means there are 6 red balls. And first urn contains 4 blue balls. Second urn contains 6 blue balls. And third urn contains 5 blue balls. So all you need to find, dear students, is that what is the probability of U1? Probability of U1, dear students, if you look into it, is 1 by 3. Because you have 3 urns and you are going to select any of this urn. 1 by 3. Similarly, probability of E2, that should also be 1 by 3. Correct or not? And probability of E3, that should also be 1 by 3. Correct? I repeat, there are 3 urns and you suppose your eyes are closed and you want to choose any of this urn. What is the probability? 1 by 3. Probability of E1 is 1 by 3, probability of E2 is 1 by 3, and probability of E3 is also 1 by 3. Now, dear students, what is the probability of, so we found this probability, E1, we found it out, E1 here, E2 here, E3 here. So one step we have proceeded. Now we need to find the value of probability of A subject to the condition E1 has happened. What is literally meaning of this statement? That means U1 has happened, means you already choose the first urn. Now tell me, what is the probability that the drawn ball is red? Obviously it will be 6 by 10. That is equal to 6 by 6 plus 4. That is equal to 6 by 10. Correct or not? I repeat once more, dear students. Probability of A subject to the condition U1 happened. That is probability of A slash U1. Probability of A slash E1 means what? E1 has happened. E1 has happened means what? First urn is already selected. Now you are going to find the probability that what is the probability that drawn ball is red? Now in the first urn contains total number of 10 balls, out of which 6 are red balls. So the probability should be 6 by 10. Correct or not? So 6 by 10, if we simplify, we are going to get it 3 by 5. So this is equal to 3 by 5. Now, what is probability of A by A slash E2, not by A slash E2? That means that E2 has happened. That means you have selected the second drawn, a second urn, and what is the probability that drawn ball from the second urn is red? That should be 4 by 10. Why? Because the second urn contains 10 balls. Out of those 10 balls, 4 are red. So the probability of that the drawn ball is red is that 4 by 4 plus 6, that is 4 by 10. Correct? So 4 by 10. So 4 by 10, if you simplify, dear students, so it will become 2 by 5. Now let's come to the third one. What is the probability of A slash E3? That means E3 has happened. That means third urn is selected. Now what is the probability that the drawn ball is red? The third urn contains 10 balls, out of which 5 are red. So what is the probability of A by E, probability of A slash E3? It is 5 by 10. 5 by 10, dear students, is actually 1 by 2. So we found all the required probabilities in the right hand side of the equation 1. So just we need to apply all these values. So from here what we can say is that probability of U1 subject to the condition A has happened is equal to probability of U1. Probability of U1 is equal to 1 by 3, right, into probability of A by U1, that is 3 by 5, divided by probability of U1, that is 1 by 3, into 3 by 5. Okay. Then plus what we can write is that probability of E2. What is probability of E2? That is 1 by 3 into 1 by 3 into probability of, A by E2. A slash E2 actually. A slash E2 is equal to what? 2 by 5. So that is 2 by 5. Plus probability of E3, that is also 1 by 3, into probability of A slash E3, that is actually nothing but 1 by 2. Now if we simplify further, dear students, what you are going to get is something like this, that I'm not spending time in simplification. We will get it is actually 2 by 5. So what we get, dear students, the required probability, that is once we know that drawn ball is red, then the probability that that drawn ball is actually drawn from the first urn is nothing but probability of E1 slash A, and that required probability we get it as actually 2 by 5. So this is a proper application proper illustration of Bayes theorem. Now dear students, you will get numerous such examples in the online platform at KonarClasses.com. You need to practice from there. But what I want to suggest to you is that after reading that problem statement, first you need to decide what are my E1, E2, E3 like these events. Means what are my mutually exclusive and exhaustive events by looking into the problem statement. And then you need to find that what is my event A. And then finally you need to find that what probability I really need to find. I just want to revisit that problem once. If you see, the problem statement is that there are 3 urns containing both red and blue balls as mentioned below. First urn contains 6 red balls and 4 blue balls. Second urn contains 4 red balls and 6 blue balls. And third urn contains 5 red balls and 5 blue balls. Now one urn is selected at random and a ball is drawn from it. If the ball drawn is red, find the probability that it is drawn from the first urn. So just by reading that problem statement, I understood my E1, E2, E3 should be the selection of these 3 urns, and that's why we have designed these 3 events E1, E2, E3. And what is my event A? Event A is that a red ball is drawn. That is why the event A. And what we really need to find, that event A has occurred. That means drawn ball is red. Now I am going to find what is the probability that it was drawn from the first turn. That means what? That means we need to find probability of U1 subject to the condition A has happened. Probability of U1 subject to the condition A has happened. That is what we need to find. Once you design this entire events and what you need to find, the rest is pretty simple. Just application of the Bayes theorem. And what you see here in the equation 1. So dear students, and the confidence you can build that how to select E1, E2, E3 and how to select the event A just by means of some practice. Okay, and as I said few minutes back, the right platform to make this enormous amount of practice is the online test platform at KonarClasses.com. So with this note, I would like to conclude the class for today. But before concluding, my humble suggestion to each one of you, please visit www.KonarClasses.com and look for video lectures, appear for DPPs, that is daily practice problems. Then you can appear for PTs, that is known as practice tests. Then you can appear for UTs, that is called unit tests. Then you can appear for MDTs, that is known as module test. And finally you can appear for MTs, that is called mock tests. And a great rank will be in your hand and a great score in your corresponding board examination must happen. Now for any assistance, please feel free to contact. Let me write down the contact number here, dear students. So you can email is that contact at KonarClasses.com. Let me write it little in the left hand side. Contact email is contact at KonarClasses.com, or still it go in the left hand side. So let me go a little further left, or I can reduce the font a little bit. Contact email, dear students, is contact at KonarClasses.com, and you can call WhatsApp to the number 80950100670. With this note, dear students, I would like to conclude the class here, and we will make more practice in our next class. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you very much.